Hello everyone, my name is Yata. It's my honor to be invited to give a presentation. Next, I will give an introduction of the design of my AI, SuperJong. This presentation will be divided into four parts. First, I will give an overview about SuperJong. And secondly, I will introduce the feature and the model design of SuperJong. Thirdly, the training methods will be introduced. And finally, I will show you the result which SuperJong gets in IJCAI 2020 Mahjong AI Competition. The main algorithm used in SuperJong is a reinforcement learning algorithm. The model architecture in SuperJong is a deep CNN, and we use global value during training, which not only contain visible information but also invisible information. And based on the reinforcement learning algorithm, SuperJong trains through self-play from zero, which is asynchronous training. In the parts of feature and model design, I will first introduce the feature design. In order to use the advantage of CNN, we encode most of the relevant information into image-like features, which includes the player's hand, the player's choice, pawn, and coin, the player's concealed coin, the player's discard, the other player's choice, pawn, and coin, and the concealed coin, and the other's discard. Because other's concealed coin is invisible, so we use a fake card to replace it. The above information is all visible information. In order to make the AI predict the value more accurately, we also use others' hand and remain deck in our training process, and they are also encoded into image-like feature. As seen in this slide, we design a reflect table of feature encoding. Different position in the 4x9 feature map corresponding to different Mahjong tiles. And in the encoded features, 1 or 0 in the map means there is one corresponding tile or not. The feature has 4 channels because the number of each tile in Mahjong is 4. So the shape of each image-like feature is 4 multiplied 9 multiplied 4. And you can read the reflect details in this example. In addition to the image-like feature, we also use some vector feature. Here I will introduce the high-level feature, 上弧 feature. 上弧 means the shortest distance from our current hand to one winning hand. In Mahjong, there are so many winning hands, and we can transfer our current hand into one winning hand by discarding some tiles we don't need and get some tiles we need. In fact, the process to get the 上弧, to get the needed tiles, and to discard the no needed tiles are the process to win this game. So we constructed the 上弧 feature as the input feature in SuperJong. And it's really helpful to speed up the convergence of the training process. As for the model design, we construct one single end-to-end neural network. inputs all relevant information, and finally, the policy network outputs the probabilities of all actions. The value network outputs the state value, and in the training process, we use the global value to make the network predict state value more accurately, and we just use the policy network in the inference stage. As shown in this slide, we apply residual blocks to transform the image-like features. There are totally 3 stages with 3 residual blocks and 1 transition layer in each stage. The transition layer is a pointwise convolution with 1 multiply 1. Subsequently, the transformed image-like features are reshaped to a vector, which is concatenated with the other feature vectors. Fully connected layers then used to transform the concatenated feature vector, and 2 branches with 2 fully connected layers each output the action probabilities and the state value respectively. As for the global value part, we just use fewer residual blocks. As for our training methods, we use a proximal policy optimization algorithm, which is a strong reinforcement learning algorithm and is widely used. In addition, we didn't use any human data. We trained SuperJong through pure self-play from zero start. During the training process, we found the variance of value loss is very high. This is because in the Mahjong game, the scores of different winning hands vary greatly. Therefore, we use the reward norm to shrink the difference between different rewards and effectively make the training process stable. Besides, the reward norm can prevent the pursuit of a high score and cannot win to a certain extent. The detail of reward norm is shown in this slide. Finally, SuperJong won the championship in the IJCAI 2020 Mahjong AI Competition. Thanks to my teammates and the organizer of this competition. The above is my presentation. Thanks for listening.